On behalf of the director, Alberto Jimenez, who unfortunately can't be here with us today, I'd like to welcome you not just to the workshop, but also to ESAC. I think also part of any welcome address is to debug the equipment, and so my first warning to all speakers is that this is really unstable, this platform. So for people following, tread carefully, literally. So I'd like to say a few words about ESAC and its history, just to give you a little bit of feeling for what we are and what we do. History goes back a long time to the early mid-70s, when it was chosen as a site to develop a tracking station to support the IUE satellite and also the observatory, which supported operations one shift out of 3, with the other 2 shifts being handled from the US. So the station, which in those days was known as Vilspar for Villafranca, Spain, opened in '78, and for the next 3 decades, it supported a variety of astronomy missions, IUE for many years, ISO, the Infrared Space Observatory, for a number of years, and then XMM in the late 90s, support which continues to today. In the early 2000s, the work of the site was expanded to cover the planetary missions, particularly our missions to Venus and Mars, and later Rosetta. And in parallel to this, the work of tracking continued, but in 2005, the big 35-meter antenna, Cerberus, which is about 50 or 60 kilometers to the west of here, opened, and that is now more of the focus of our tracking activities here. And in a recognition of the change of focus from tracking to science, it was renamed ESAC, the European Space Astronomy Centre, in 2008, and was reopened or rebranded, I suppose would be the appropriate phrase nowadays, by the Prince and Princess of the Asturias before he ascended to the throne of Spain, became King of Spain. So the current activities, the main activities, we still do some satellite tracking from here. You see some of the antennas as you walk across the site. Most of our work is looking up and out, but contrary to the main thrust, we do host the Spanish National Center for one Earth observation satellite looking at soil moisture and ocean salinity. We host in the other part of this building, part of the Spanish National Astrobiology Center. We host elements of the ESA program on space situational awareness. And one of the newer developments is support to the science of Galileo. Now, Galileo is the EU-funded, ESA-implemented GPS system, and all those satellites whizzing around there with high-precision clocks give opportunity for tests of general relativity and other science applications. So a small office to try to exploit those data for scientific purposes is being set up. But the main activity on site remains linked to the science program, and I'll come back to those 3 bullets several times in the next few slides. So the core mission of the site now is the Science Operations Centers for ESA's astronomy, heliospheric and planetary missions. We also host data archives for most of those missions, providing long-term access to the data. And we have the responsibility for overall management of the science program's missions once they're commissioned in orbit. So I can't really go much further into what we do without taking a slight backward step and looking at the science program as a whole. So let me just, in a few words, try to encapsulate the ethos behind the science program. It's the space science program. It's science-driven, and it's a bottom-up program, i.e. the processes involve the community proposing themes, proposing missions, proposing instruments via responses to calls. We rely on the broad scientific community for input, for peer review. And one committee, the Science Program Committee, decides the program content based on the recommendations of peer review committees composed of scientists. Another characteristic of the program is its mandatory nature. All 22 member states of ESA must contribute to the science programme in pro rata to their gross domestic product. This gives us, the overall budget is decided every few years. The overall budget can go up and down a little bit, but all the member states contribute to that envelope. So this allows long-term stability and long-term planning of its science goals. And the long-term nature of the programme is also a key characteristic. It's necessary to be able to plan ahead so the communities know which missions they're getting, which missions they're not getting, unfortunately, and people can make preparations to optimally exploit missions when their data streams come online, and also to make plans to use that data long term. We've been doing long-term planning since the 80s, and I'll just touch on that in a minute, but the message I want to leave you from this slide is continuity and stability for the programme. The current long-term plan is called Cosmic Vision. It originally covered a 10-year period from 2015 to 2025, but was expanded to cover an additional decade. It's aimed at addressing fundamental questions. I won't read them out to you. You can quickly look at them yourself. They cover basically all of astronomy and a lot of societal questions as well. And the idea is that missions that are selected in response to calls for proposals address some elements of those bigger questions. So let me briefly move on to the elements of the programme, and I'll just in the next 3 slides walk through those missions so you can have some idea of the scope of the programme. These are the missions currently in development, moving towards launch, and there's quite a big cluster of them scheduled for launch in 2018. So in this group of half a dozen or more missions currently in development in their industrial construction phases, we have Cheops, a small mission, Swiss-led, characterizing exoplanets. We have Bepi Colombo, a joint mission with the JAXA, the Japanese Aerospace Agency, which will take 2 satellites to orbit Mercury. We have Solar Orbiter, a mission in elliptical orbit going close to the Sun. We have James Webb, which I think you here know more about than I do, so I'll move on. In 2020, currently scheduled for launch, we have Euclid, mapping the dark universe. And further downstream, we have a major mission to Jupiter, JWST. I do like all these contrived acronyms. I think amongst them all, JWST must be the one I hate most, I'm afraid. Apologies to any planetologists or aficionados of Jupiter here. And Plato, an exoplanet transit and stellar oscillations mission, which has passed the first stage of the 2-step selection process, but is waiting for the second step of that process, a confirmation which should happen later this year or early next year. So those are the missions in the future. Current missions delivering data to work on. I split them onto 2 slides. Here's astronomy and fundamental physics. I think the longest lived mission so far is Hubble, ESA's contribution to the Hubble Space Telescope. As I mentioned earlier, XMM was launched at the end of the 90s and was designed for a 10-year mission and is still going strong. And I think regularly the X-ray astronomers have conferences called the next 10 years of XMM. So there is planning ahead and optimism there, and it's an extremely productive observatory. Integral, a unique observatory at high energy wavelengths, hard X-ray and soft gamma. Then 2 missions in the softer regions of the spectrum, the far infrared and microwave, both of which were cryogenic, both of which have finished their active life in space, and the satellites themselves have been disposed of, very, very cleanly disposed of, but we're still in the post-operations phase of those 2 missions. Herschel, the final data sets are still being readied, and the archive then will be available for mining and use in preparations of other missions, like the one you're here for this week. Planck, the final data release is expected towards the end of this year, early next year, and again, then that becomes a data set to be preserved in our archives for use and reference for many years to come. One of the current stars of the show is Gaia, which had its first major data release just last week, Gaia DR1. And it was interesting to see the first submission to AppJ took about 12 hours after the catalogue was released. So congratulations to those people. And there were several very rapidly followed that. And also in orbit at the moment, we have LISA Pathfinder, which is demonstrating the technology needed for future gravitational wave mission, and basically outperformed its spec out of the box. So it's been very successful in orbit. A lot of excitement closer to home on the heliospheric and planetary side as well. Again, the longest lived mission here is SOHO, studying the sun from the L1 point. And I think this satellite basically invented the whole concept of space weather and continues to monitor the sun to this day. Cassini-Huygens. Cassini itself is still operational, the NASA mission, and is scheduled for a fiery end next year, plunging into its planet, whereas ESA's contribution was the Huygens probe, which landed on Titan in 2005, and that remains still the furthest away soft landing of any space mission. Cluster, 4 satellites sampling the Earth's magnetosphere and tracing out the Sun-Earth interactions. Mars Express, in orbit around Mars and providing spectacular images. Rosetta, which is, has spent 2 years in close orbit around its comet. And key date here, 30th of September, a couple of days away. We are going to put Rosetta in a controlled impact, put it down on the surface of the comet and end the mission. We're now so far away from the sun that we have a limited data rate to get data back and limited power to operate the instruments. So it's time to park the mothership on the comet, and then move on to finalizing the data sets. Venus Express was for nearly a decade in orbit around Venus and entered the Venus atmosphere last year, and now those data sets are being finalized, and I believe that will close out any active work on Venus Express in the next month or two. Proba 2 is a little technology demonstrator which also gives a return on solar observations. And another date in the near future, the ExoMars 2016 mission, the Trace Gas Orbiter, is on its way to Mars. And on 19th of October, so just a few weeks away, we will put TGO into orbit around Mars. Around Mars, sorry. And the Schiaparelli entry descent module will be released and will touch down on the 19th of October. So that's the program we have. As I said, the operations department here looks after the SOCs and the archives and the overall management. We've got we're involved in over 25 missions and studies. I didn't mention the studies in the previous slides, but there are always a number of those underway. We have over 250 scientists and engineers involved, mainly here, but also at Space Telescope Science Institute, Goddard Space Flight Center, ESTEC, etc. What we do is we usually partner with member state institutes, and depending on the mission, we use some or all of these activities. Interfaces to users, including activities such as workshops like this one, to promote knowledge, to prepare people to exploit missions. We're involved with our partners in payload operations, scheduling and deconflicting the timelines of operations, monitoring the payload, quick look data analysis, then the offline data processing, the pipeline processing to produce products to be distributed, distribution of software for interactive analysis so people can tune up the products, data archiving, long-term data archives and distribution, and a lot of software and procedures. Returning briefly to the archives, we have a large number of archives online. On the planetary side, we have active archives at the moment, like Rosetta, Mars Express, and more historical ones, Giotto, Venus Express, Smart 1, and Cassini-Huygens. On the heliospheric side, the active archives, Cluster, SOHO, and the more historical ones, Double Star, Ulysses, etc. One of the nice new elements here is we've recently, in the last couple of weeks, put online an archive of data from one of the solar experiments on the space station. But you're probably more interested in the astronomy side, and again, the big active archives, the European Hubble Space Telescope Archive, the XM Newton Archive, and the Gaia one, and more historical ones, EXOSAT, ISO, and still very actively used, although not being ingesting new data, Herschel and Planck. And of course, as you will hear in a talk later in the week, you can view all this data either through the Direct Archive interface or through a new interface called ESA Sky. And this is the home screen that you get when you log into ESA Sky. And here's a result of some work with using XMM observations. But you'll hear more about that from Bruno Merin later in the week. So to begin to finish, this, I think, is just a couple of results from different missions to remind us of why we go all through the blood, sweat, and tears of developing SOCs, developing archives, and serving a variety of communities worldwide. So an HR diagram from some of the early results of Gaia. This may even be slightly out of date. It may be based on some of the pre-release DR1 data. Planck data, all sky cosmic microwave background, both temperature and polarization maps. SOHO results, studying the sun and watching coronal mass ejections. Herschel, detection of water on the dwarf planet Ceres. One of my favorite Rosetta images is just blinking two images. And if you look, they're a couple of seconds apart, these images, and I hope you can see a jet appearing there. I hope that's visible to you all. That's just a couple of seconds apart, comes on like that and goes. And whenever I see that, I think, my God, how did we maneuver a spacecraft within a couple of kilometers of that sort of environment for so long with relatively few excursions into safe mode? Rosetta, of course, mapped very nicely its nucleus with the original surprise of the shape of it. And of course, you get thrown the occasional crumb of joy, like, last month, finding Philae. So here's the head of the comet. If you take that area, blow it up, you get that. And it's like one of those quizzes on the internet. You know, can you find something in this image? And in fact, in that small corner, when you stretch the intensity scales, you get what really blew me away, a really good image of Philae. It's 5 centimeters per pixel, the image scale. And when somebody said they'd found Philae, I was expecting a blurred image, which you had to, maybe I can believe it. But that is really believable. So to begin to wrap up, welcome again to ESAC. You've been wise enough to come early enough in the year, so that's not the view you've got at the moment, but in midwinter that can be the view you get here. So what I'd like to do is wish you well with your JWST preparations. This is the first of 3 workshops, so it is, I think the title of the workshop implies that it's a sprint. I suspect it's more like a marathon. So I wish you all the best of luck, both to enjoy this workshop and also in your preparations for the eventual observations you'll get. Many thanks.